Good morning. We'll be starting up here in just a minute or so. And no, don't adjust your screen. We're just trying to make sure things are working. Okay, good morning. We're going to go ahead and get started. My name is David Orr. I'm the director here at the New York State LTAP Center and the Corner Local Roads program. And today we're going to be talking about work zones, work zone traffic control, a little bit of the why we do these things. Our instructor you may have seen before in some other of our webinars is Al Bachner, who's out on Long Island, and I'll let him tell a little bit more about himself, and we'll go ahead and get started. So Al, I'm going to go dark, and Amanda, Adam, and I will watch in the background. Make sure things
Okay.
keep running smoothly, hopefully.
Good morning, David. Thank you. Welcome to Work Zones, the why. A little bit about my background. I worked for New York State DOT here on Long Island, Region 10, for over 30 years. I also work at the Nassau Community College as an adjunct instructor, and I've been there for a lot of years teaching in their engineering, physics, and technology program. And today we're going to take a look at the work zones, the why. But first, let's get a little background and see where our audience is from. I understand we have almost 150 some odd viewers today. Okay, it looks like the bulk of our population is from towns. And let's get an idea of what type of, oh, great. Okay, looks like we have a lot of engineering personnel today. Good morning to you, highway superintendents, some of the people working in the office. I'm not sure what our little blue area is. We got 10%, none of the above. And there's the people that a lot of the address will go to is the field crew. The people are actually out there putting those cones out. And it's very important to them, this presentation. And hopefully the people that supervise them and get them the materials and the support that they need, or put together the plans for them as the engineers and the highway superintendents, it's important to them to make sure the field crews have the materials they need, the support they have. And let's see what type of experience we have. So we got a bulk of people that have been working for over 5 years. That's fantastic. Now, this program is obviously a 1-hour presentation, and it's gleaned from our 6-hour class. So it's kind of the Reader's Digest version. And in the class, we call on a lot of participation and learn from the experience of our participants. If you have an opportunity to go to one of our in-person classes, we'd love to have you and learn from your experience as well. And Amanda, I see that there's some things in the chat there. If there's, I'm having a tough time with the with the technology. If there's something I should be aware of, chime in and let me know.
Yeah, we'll step in. Al, don't worry about it.
Thank you, David. Oh, we got a big concentration out from the western end of the state. And perhaps some of you have taken this class with Ken Swain, also an old DOT, New York State DOT alumni. And we just got a smattering of people from the Long Island area. Okay. So here we are. Why work zone traffic control? That's a big question today. I'm going to give that question to you and ask you, why do you think work zone traffic control is important? Saves lives, prevents accidents. Safety, that's usually the answer I get in class. Overall, that's like mom and apple pie. It's the overall umbrella answer. Okay, I like that one. I don't want to die. The person who wrote that, are you a person who works out in the field? Ah, okay. That's a good one. Protects the workers. A high respect for drivers there. Okay. Okay. Let's move along and see what we got in the program here. So I believe, and one of the key reasons I feel this program is important and work zone traffic control is important is because it protects employees. The field people, the people who are out there, that 14% that we saw earlier, they go out there and their job is very different from people who work in the office. People who work in the office, their biggest concern is they'll get a paper cut or they'll bruise their hand when the stapler malfunctions. But people who work out in the field, we all get up in the morning and we say goodbye to a loved one and we kiss them and we're off to work. And there's an anticipation, an expectation that we'll be returning that night. But the people who work out in the field, they work in a very different environment. Their office is the roadway environment. And out in that environment, there's lots of moving vehicles, anything from bicycles to big trucks and buses that are traveling down our roadways. And usually in class, I ask, what kind of speeds do these vehicles travel on your roadways? And we'll get a variety of speeds. Some people tell me that they have vehicles going down their roadways at 50 to 70 miles an hour. But just even looking at at something less, just a village street, it's probably that you're working in an environment where vehicles are going down your streets at 40 miles per hour. I think we can all agree that we've worked out, and that's a typical day where we're making our way through vehicles, heavy vehicles traveling about 40 miles per hour. And you make one mistake out there, have one misstep, and you're not going home that night. And in fact, people at home will be getting a call and they'll be making arrangements, either making arrangements to visit you at a healthcare facility or sadly other arrangements. And at DOT, I can recall having the phone ring in our design office and being told that there was an accident on a construction project and one of our employees had been injured. So what I'm looking at is the material that we'll be presenting today. Maybe there's one thing that you pick up on, and it keeps you safe, and it keeps you it keeps you from getting hurt. So it also protects the public, and we have a very dim view of the public, some of us working out there, because they go by us and they yell things about our family. They seem to know a lot about our family heritage, and they usually put up a finger to tell you number one. So we get we kind of get calloused over with the public, but what we have to do is think about the public, put a face on the public. Think of somebody you love. Somebody you love is going down the highway today, and they're going to be going through a work zone, and you want them to get through safely. So as we design our work zones and we work out on the roadway, we want to think about getting the public through safely. Improves productivity and it saves money. Now, nobody goes to work thinking they're going to bring the state or the town or the village in on the budget. But it is true that if we work safely, our productivity goes up and we all have a better day. And it reduces liability. Now, liability. Why liability? That's always a sore point. People will say, oh, that's why the supervisor sent me to this class. The village, the town's concerned about their liability. Well, I look at liability in a different way. Why is there a lawsuit? Somebody got hurt, injured, and then there's typically a liability suit. But if we do our job right and we do it well, then perhaps that accident, that incident doesn't occur. And if we can reduce liability, it means that we're working safer. Now, in some of the classes, people will say, well, can't we eliminate liability? Well, you're never going to eliminate liability. There's always going to be somebody who's going to sue your municipality or your entity that you work for. But if we work smart and we do things the right way, we can reduce our liability, and we're working safer. We're keeping ourselves safe and the public safe. What do we want to do? We want to look at liability, standards, and some people get upset with standards. They say, oh, standards, that's something they're going to measure me by. That's the yardstick. They're going to say, be able to say whether I'm doing my job right or not. I look at standards in a different way. Standards are a guide or a meter stick that helps us to know what to do. It gives us the directions. And of course, there's the traffic control devices. Those are the tools that we use to do our job correctly. And we're not the first people going out there to patch a pothole or replace a water main or remove a downed tree or a dead animal. So this has been done all over the country. And we have some typical applications that'll help give us ideas or show us the right way to do things, and we can apply those. In order to minimize liability, we want to have a plan. You want to know what you're going to do before you get out there. So you have the right material, the right people, and there's no confusion when you arrive at the site to set up. We want to follow something called the New York State Manual on uniform traffic control devices. And we'll talk a little bit more about that. It's sometimes the acronym is pronounced as MUC, so you might hear that. We want to minimize traffic disruption and properly remove our devices when we're done. And here's the reason why we're probably all here today. We want to train our people. We want them to know what to do and how to do it correctly. For reducing a liability, we want to have a routine inspection schedule. We need a report form so we get it in hard copy, and I'll show you some ways to do that later on. If there's a hazard out there, identify it. Again, adequate personnel and inventory. The right signs to be placed in the right places. Document the repair, and the documentation has to be formal, not on the back of a napkin or on the cover of a coffee lid, but we want to have a formal documentation that we can put into a file. And we want to have, of course, have our plan, keep disruption to a minimum, make it short in duration. Why make it short in duration? Because the less time we're out there, the less exposure we have to getting hurt or somebody getting hurt. So we get in and get out quickly. And remember your image, do it in a professional manner. And this seems like keep it simple. So many times in my career, when we were asked, I worked in traffic engineering and safety in Region 10, Long Island. And so many times we were asked to set up a work zone and people would say, oh, let's make it confusing. So we slow the driver down. And that's a mistake. What we want to do is we want to keep it simple, provide the driver one simple path. So we minimize the amount of decisions the driver has to make, because every time we give the driver a decision to make, there's a chance they'll make a wrong decision. So keep it simple. And here's a character you might have seen, and the question is, why do people have incidents? They don't call them accidents anymore. They're incidents in work zones. Why? Well, the driver didn't see something. The driver didn't know what to do, or the driver didn't know where to go. Well, that's on us. If we're out there, we've got to make sure that when we set up our work zones, we give good information to the people coming into the work zone. And a good way to do that is after you're set up to drive through and observe the site. And so you can see exactly what the driver sees. Now, the driver didn't have time to react. We'll spend a little bit more time on that in a moment. And so many times we just ignore our work zones and stick workers and equipment in a traffic lane. We want to keep the traffic lane open for traffic. So when we're talking about reaction time, we have to have time to see. Oh, geez. Our program, or my program, has frozen up. Amanda, you there? Thanks, Amanda. What could go wrong with a PowerPoint presentation? Go ahead. Go get up the 4 bullets. Thank you. So let's see, a reaction time to see. Let's visualize a car driving down a village street with parking on both sides. A ball rolls out from between 2 parked cars. It takes time for the driver to see that. When the driver sees that, the next thing that occurs is they got to process. What does that mean? A ball rolling out from between 2 parked cars. Well, it means that there's probably going to be a child following the ball, not just the person, a child. The child is not going to be mature enough to think about traffic. The main concern is going to be following the ball. Time to plan. Now the driver saw the ball. He processes that a child will be following it. Now he's got to go through the process. What do I do? What do I have to do? And then finally, he decides that he'll move his foot from the gas to the brake. So that all takes time. And that's what I'm talking about when I talk about reaction time. Thanks, Amanda. Next slide. So we have, not everybody out there is paying attention to the roadway. We have people out there that are doing other tasks in the car. They got personal grooming, they're texting. Nowadays, our children sit in the back seat, and when little Johnny acts up, the parent's first attention is to the child. And people are going down a highway, and they may have had a drink or two, and they may have gotten some drugs. And not everybody's getting their drugs in CVS. There are people who are getting their drugs behind CVS, and they're all going down our roadway. And that's affecting their reaction time. If you've ever noticed on your drug packet, if you take a cold remedy, it says don't operate heavy equipment. Well, a 3,000-pound car is heavy equipment. A distracted driver's reaction time, the feds have estimated and used 2.5 seconds for the distracted reaction time. Next slide, please. Now, the question is, how far does a car travel? And let's use just a modest 40 miles per hour in 2.5 seconds. Slide. So that seems like a simple calculation. It's a rate times time problem. But let's see, it's 40 miles per hour and our time is 2.5 seconds. We have mixed units. The speeds are miles per hour and the timer in seconds. Okay. So we have to do a conversion. Oh my God, this goes back to what, junior high conversions? 40 miles per hour to feet per second. How do we do that? It sounds like a job for mathematics. Let's see, maybe we got a simple rule we can follow. Write the speed miles per hour. So write that down, that's 40. Then write half the speed of 40, half of it is 20. Add them up. What do we get? We get 60. We've just done it. We've converted 40 miles per hour to 60 feet per second. But the trick here is 60 feet per second is a little bit more than 40 miles per hour. Why is that? Slide. Well, what we did was we took 40 and we added 20 to it to get 60. And that's the same as if we did the operation of multiplying 40 by 1.5. 1.5 being a conversion factor. Well, the actual conversion factor, if we followed through all the units, would be 1.47. But we'd probably all round up to 1.5. So 60 feet per second is a little bit more than 40 miles per hour. And slide. What's the distance traveled? If we're traveling at 60 feet per second, in the first second, we travel 60 feet. The second, another 60 feet. And a half a second, 30 feet. So in 2.5 seconds, the vehicle's traveled 150 feet. Now we're going to have to do this calculation every time we want to set up a work zone or put a sign out on the highway. Absolutely not. Those standards that we talked about earlier, why do we have them? Because they take this into account. So why do we go through this? So you understand why we put those signs out at some distance in advance of the condition. And you respect that. How many times have you gone out and you've seen a work zone with the sign just at the tailgate of the first truck? No, we got to get those signs out and we have to follow the standards. So now you have an understanding of why those standards are there. Now, the highway safety concerns, we're concerned about traffic control, equipment operation, material handling, excavation safety. Equipment operation is a simple task like doing a paving job. The equipment we might be using is the rakers might be out there. Where do the rakers stand? They stand on the high side of the operation. If you're on a standard 2-lane road, the high side is probably on the crown of the road. When they pull the rake back, the rake handle will be going into the open lane. You have to be aware of that. Slide. Traffic controls, we'll be looking at that. But the first, we'll ask you a question. How can you minimize or eliminate problems in work zones? What do you think? Follow the standards. Good. Plan. Okay. Well, you people have some good ideas. Oh, somebody wants to use automatic flagger devices. Okay. Okay. Obviously, we got some people who have some good ideas here. Very good. I'm impressed. Well, it's simple. I think you all captured it. Follows the established standards. Where do we find those standards? Let's take a look. We have something called the Manual on Uniform Traffic Control Devices. Now, remember, what we want to do is we want to communicate with a driver who may be going at a modest 40 miles per hour, and we want to communicate an idea that driver might be distracted. We want to communicate an idea. So what we do is we use uniformity, and the manual has gone over some changes over the years. In fact, the new manual is due out shortly. And in New York State, we have the national manual and we have a New York State supplement that we need to follow. You probably have all these books on your bookshelf somewhere. Don't throw out the old ones. You might need them to defend yourself in a case that from devices that were placed out there when that book was in vogue. So where can you get this book? Let's take a look. Slide, please. Oh, this is an excellent standard or an excellent resource. Cornell Local Roads puts out a traffic sign handbook. It's kind of a Cliff Note version of the manual. And if you're not familiar with the manual, one, you could take our class. We have a class where we take you through the manual. But if you haven't had the class, you're not familiar with the manual, this handbook is a good resource, because if you notice in the third column, you look up a sign like the stop sign, it'll tell you what sections to go to in the manual. Slide, please. These manuals provide the standards that we need to follow. And it's just not a good idea or not just a resource. Actually, under New York State V&T law, hit it again, section 1680A, it's actually law, and we are obligated to follow it. Now, since it's a law, the words, well, we use words in law, they have very special meanings. And we'll find the words in the manual standards or shall. That's an absolute mandatory condition. So when the manual says a stop sign shall be read and have 8 sides, we have no discretion. A stop sign shall be read. No discretion. One village on Long Island, the mayor wanted to put up yellow stop signs because, it was a historic village, and that may have felt that those old stop signs would give it a nice cutesy look, but was not allowed to put them up because the stop sign is a shall be read. Then guidance, you'll see the word should. If you're looking to put up a curb warning sign and it says it should be placed 200 feet in advance of the curb, and you go out there and paste that out, and 200 feet comes out in the middle of an intersection, well, that's not a good place to place a sign. You go back to the manual, it says should or guidance, then you have some freedom to move that, or discretion to move that sign in advance or after the intersection. And then you'll see the word options or may. And there you have complete discretion. And you can read what the manual says, or you should read what the manual says, and then you can decide whether or not you want to take that action. Another word you'll see in the manual is support. Sounds like an important word. Well, it's an important word in the respect that it just gives you references to the item that you're reading about. Slide, please. And again, the manual is set in law. We're all obligated to follow it on all our travel ways, regardless of the type, the class, or whether it's a public agency having jurisdiction, even on private property, like ring roads around the shopping center. Now, as I travel around the state putting on this class, generally when we're having a cup of coffee, people come over and say, Al, all this stuff's very nice. And you're from Long Island where there's a lot of traffic, so you got to follow these, and we can see that. But we're up here in East Cupcake, and we're in the Hitherland, so it really doesn't apply to us. And then when I come down and put on a class in an urban area, people tell me, well, this doesn't really fit us. This is up in Hitherlands and East Cupcake where there's lots of open roads. And the truth is that these standards are for all our roads, regardless of if it's urban or suburban or rural or farmland, whatever it is. We're obligated to follow these principles and these standards. Slide, please. So what are the devices we have? These are the tools we have. Signs, traffic signals. Now, not too many control traffic signals. And when we have our 6-hour class, we go into a little bit more on that. And many of you are out there just for a short operation. You're not going to change paper markings. So we got to think about how we can use delineation or channelizing devices to have vehicles violate the pavement markings. And in our 6-hour course, we have an afternoon section where we cover flagging, and we go more heavily into the hand signaling and lighting and warning flags. Slide, please. The traffic control devices must fulfill a need. They have to be visible. They have to be standard. Slide. There's a standard sign. That's a beauty. That's up in New Hampshire. Go ahead, another slide. And just when you thought it couldn't get any worse, we got an artist out there. Another slide, please. And here's a standard. Who wrote this one? This looks, you can see this slide's dated. This sign must have been, they must have had a wannabe lawyer in their office when they came up with this sign. And also the posting height is wrong on it. We want to give one clear message. Go ahead. And our signs and our devices have to command attention and respect. Now, for that, we're making a judgment call. Next slide, please. So we have to. We all know what a new device looks like, but is it acceptable? Is it marginal, or is it something we absolutely shouldn't use? Now, ANSA puts out this guide, and what this guide does is it takes the words from the manual of what's acceptable, marginal, or unacceptable, and it puts it into a picture format so we can make that call. And here we have some cones. Now we have 2 columns of cones. What's the difference between the 2 columns of cones? One has white stripes on it, the left column, the right column doesn't. What's the difference? Why do we have that? Well, the right column is for daytime use only. The column with the left stripes have, the left column has those white stripes. That's okay. Slide, please. And some of us say that they're reflective. Others say they're retroreflective. What the heck's the difference between reflective and retroreflective? Slide. A mirror is reflective. Here we see an incoming light beam. It strikes the surface of the mirror. It makes an angle. The incoming light beam makes an angle with the mirror, and the beam leaves the mirror at the same angle. So that's shown in this slide. Next slide, please. This is retroreflective technology, and this is from glass beads. And the physics of it shows us a light beam coming in, and it's moving from one medium, air, into the glass bead, changing the medium, and the light beam is bent. That's called refraction. Then the light beam hits the back surface of the glass bead, and it's reflected. And as it comes out again, it goes from the glass bead, one medium, to air, and the light beam is again bent. It's refracted. So the physics of the of the light. And here we can see reflective compared to retroreflective. If our signs were reflective, the beam of light from the headlight would hit the sign and light up the roadside. But our signs and our devices are retroreflective. Slide, please. And here we can see what happens. The headlight hits the stop sign. It's retroreflective. It bounces the light back towards its source, and right behind the source and above it is the driver. So we can now, we use retroreflective materials in our roadway. Slide. And let's take a moment to look at worker safety. Go ahead. Workers must be seen. Hit the, there you go. A big animation. And we're told we're obligated to have our workers highly visible. So we use ANSI class 2 or 3. Typically 3 should be used for nighttime exposure. Let's hit the slide, please. Class 2 and class 3, what's the difference? The amount of square inches of retroreflective material. And if you're a very small person, in order to get the class 3, you might actually have to wear retroreflective slacks. So why do we provide this? Why does the manual make a standard? We want to make sure that the workers can be seen in a complex work zone, and they can be seen during light or nighttime. So hit the slide, please. Oh, maybe you better back it up. Okay, back it up. Another one back. All right, there's a time slide coming up, and what we want you to do is count how many workers you see. So hit the slide, please. Okay, hit the slide. And if you look, you'll see that there are actually 7 people that we can see in this photo. One is up in the cab of the truck on the right. The important, what's obvious though, is that the workers that have their vests on can be picked up very, very quickly. The police officers that are out there, they have sidearms and they don't believe that they need to be visible. But actually, they have their own vests, and they're obligated under the manual to follow the work zone safety rules as well, or standards. And you can see that you didn't pick them up as quickly. Now let's get some male models up here. Slide. Okay, we have our 2 male models here. The fellow on the left is wearing an approved vest. The fellow on the right is wearing one of the older mesh style vests. They're still available in some of the sporting stores. Joggers and bicycle riders will purchase them. What's the difference between the 2 vests? Well, one is the amount of square inches of retroreflective material. And why is the mesh vest obsolete here besides the square inches of retroreflective material? They're not visible 360 degrees. We can see in this side view that there's very little visible to the motorist for the fella in the mesh vest. Slide, please. And we have another male model this is David. And we can see that during daylight conditions, the vest helps him to be visible. And take a look at nighttime conditions. Without that retroreflective material, David would just blend into the background. Slide, please. Now you can also, we have work zones for formal affairs. This is if you have an after 5 affair. Next slide. And this is for a before 5 affair. Okay, that was just a little joke. We don't really have formal wear for work zones. Let's get back to traffic control devices. Again, So one of the things we don't want to do is mislead the driving public. Slide. I'm sure when the superintendent posted this, he felt he was saving a signpost, but we're not doing the public any favor. Slide. Now, this has nothing to do with work zones, but you can see that we could have some people scratching their heads of where it's legal to park. Slide, please. And this was put up on a state highway. I'm not quite sure what this was. Aliens dropping in from outer space, not to turn into that driveway. And when we have things that aren't right, what do we got to do? We got to get out and replace them, put up the right things. Slide, please. And not be a hazard. Now, I'm not sure this next sign is really a hazard, but you can see that this next sign would really get some people upset. And maybe in that respect, it's a hazard. Yeah, right. Imagine being caught in that queue. Now, the signs we put out there, they regulate traffic. They warn traffic of situations they might not be aware of, and they guide traffic to help them get from one place to another. Slide. Now, in following the manual, what we want to do is, we want to reduce the amount of reaction time. We want people to see our sign. We want to get information to them quickly so that they understand exactly what's expected of them. And we use color, shape, and the message. Now, I'm just going to use shape. Slide, please. Take a look at that first shape. Can you tell me what that sign is? I bet you all can. Click. Absolutely, a stop sign. The triangle, what is a triangle? Click. All right, now let's take a look at this sign. This is a rectangle with the long axis vertical. What could that possibly be? Click. It's a regulatory sign. Those parking signs we saw earlier, they had the same shape. They're regulatory signs. Then we have X's and O's. Is that tic-tac-toe? Click. Crossbuck and click. Railroad warning sign. Now, the next sign is actually a square that's rotated, 45 degrees. So we call it a diamond shape. And what color would you expect that to be? Think about it. In class, I'd ask for some responses. Click. They're warning signs. Hey, we got two colors. Well, I'm only showing two colors. And in the two colors, yellow and orange. Why are there two colors? Well, there's actually two populations of motorists that go down our roadway. The familiar driver, the person who drives that route all the time, driving to work. You go that route all the time. You drive to work, you drive home, you do it. You've been doing it for years. You probably don't look at any signs. If the warning signs that we put out there for work zones were yellow, people probably wouldn't notice them. And the other drivers we have are the new drivers. They're new to or strangers to our community. They follow every sign. They're probably the safest driver going through our work zone. So we make the work zone signs black on orange so that they stand out. Sometimes we put flags over them. We put them on posts with flags to help them stand out so they get attention. Emergency responders use pink so that they stand out. Next slide is that let's go Mets, let's go Yankees, Patriots, what is it? No passing zones. And then we have home plate, click, school zone, but click, we don't use that color anymore, click. Yeah, we use the fluorescent yellow. And the next slide, that one usually gives some people some trouble. That's a county route shield, click. And that's County Route 16 in Rockland County. And the next slide is a rectangle with the horizontal, the long axis horizontal. That's a guide sign. And here we have a work zone, so we use the work zone guide sign. Next slide, please. The work zone. What are the areas of the work zone? Click. The old manual had 5 parts. the manual we currently use took those 5 parts and condensed them down to 4 parts. Go ahead. And we'll take a look at these 4 areas in detail now. Slide. The advanced area. This is where we tell people that they're going to be coming into a work zone. We want to get their attention. We space out the signs to give them time to react, and we can adjust for field conditions. And usually we use 3 signs. Slide. General warning, specific instructions. Slide. Let's take a look at this. We'll consider up the screen north and down the screen south. We're closing off the northbound lane. So we put in the first sign, general warning, click. The second sign, click. Give them more specific and more instructions. And the third sign, click. We give them, we tell them what to do. And click again. We have to also post those sounds. Look up in the top of the slide. We post the signs for southbound traffic. Now, there's different posting. What do we do in a low speed area? They're posted 100 feet apart. What do we do? Click. In a rural area, click. We post them at 500 feet. Those are all found in the standards. Click. Let's take a look at how we're going to set up our work zone. Click. What we're going to do when we're setting up our work zone, we're actually, as we're putting those signs up, we're actually working out on the highway. So what we do is we start with the most remote sign first. And after we get that up, that's giving us some protection as we put up the second sign. You'll notice that signs are being propagated or being installed in the upper part of the slide. Click. There's our third sign. Then we drop off our flagger. Click. Get the flagger ready to set up. Then we go up the roadway. We put up the end road sign, end roadwork sign. Then click. Then we turn around. And we're coming back into the section where we're going to close. We put up the first sign. Click. The second sign. Click. The third sign. Click. We get our flagger ready. Click. We set up our cones and click, we put up our end roadwork sign. And now when we're going to take it down, we do it in a reverse order. So we're providing the signs that we're putting up and providing safety while we were out there working. Click. Here's our general warning area. We're looking at a limited access highway. Specific warning, click. Specific instructions, click. Take a look at the transition area. Here we have cones set up. We want to move traffic. We want them to violate the pavement markings. So we have to provide good guidance for them. And we have different types of tapers. Let's take a look at them. Click. Here we are on a limited access road where we're closing the right lane, 2-lane highway. Click. And if you notice the pavement striping, we can use that to help us estimate distances along a roadway. The stripes are 10-foot long with a 30-foot spacing. So from the beginning of one stripe to the beginning of the next stripe's 40 feet. We count five stripes, we got 200 feet. So it's an easy way to estimate distances along a roadway that has those skip lines. Click. What types of tapers? We have emerging taper, and the length of that is L. This is emerging taper. Click. The next is a shifting taper. Let's take a look at what that looks like. Here we're doing some work on the bridge abutment, and we had to just move. We're going to maintain the 2 lanes, but we're just moving them over 2 feet. So there's no interaction between the 2 lanes. So we use a taper length of L/2. Click. We have a shoulder taper. We're working on a shoulder. We use a length of L/3. Then two-way traffic taper, let's click on that. And that's in this condition, and that's a maximum of 100 feet. 100 feet, we use a 20-foot spacing between the cones. So 20 into 100 is 5 plus 1 cone for the end. We need at least 6 cones for the taper. And we want to put in that abrupt taper to show the motorists that the lane is closed, but not encourage them to move over to the other lane. If we put in a long taper, we would almost guarantee a head-on collision. Click. We have the downstream taper. Click. That's 100 feet. Where's that? That's click. There it is at the end of the work zone. Click. Click. Devices used in the transition area. These barricades, let's see, I'll give you a college education here. First one's type 1, move to the right, type 2, and type 3. I imagine that you can notice that the zebra striping is slanted on this. Notice the arrow is pointing to the left, click. That's because the way the stripes slant down is the way traffic should pass to the downside of those stripes. Click. So let's click. Let's take these 2 slides. Click. Let's take the slide on the right and flip it over. You'll notice the slide on the right is upside down, which is the same as taking those barricades and putting them upside down, but the stripes still slant down to the left. So when you're ordering barricades, there are left barricades and right barricades. Click. And these devices are being used in place of cones. Notice the first one on the right is slanted down in the wrong direction. If you're placing this out, make sure you have them properly orientated. Click. Activity area is a buffer zone and a workspace. Click. The buffer space, it provides a place for the vehicle that makes a mistake so they can enter it and not hurt anybody and not hurt themselves. So it's got to be free of everything. It's empty. Go ahead, click. And it's mandated by, or its length by what the speeds are. Click. And here's our buffer space. Notice the impact truck parked. When we park that impact truck, it's not in the buffer space. The back of that truck defines the beginning of the work area. Why? Because nothing is placed in the buffer space. Click. And the work area, what we want to do is we want to mark that off to define where traffic can flow around it. And an important element is that workers and equipment know that they are safe or safer when they stay within that. So workers, when you're leaving that work zone, when you're stepping outside those cones or barrels, you got to pick up your head and take a look for traffic. Click. Click. And the termination area, that just lets the driver know that they've left the work zone. Click. Click. Now, let's take a look at this. Go ahead, click through it. Click. Click. And this is showing us set up in an urban area. Click. Can you see what's wrong with this slide though, or what's wrong with this setup? If you look at the second sign, it says it's a 1-lane road. Well, they've either opened it up and forgot to take down the signs, or they're lying to us. If you're setting up a work zone, make sure that it's giving good information to the public. Don't just use signs. Oh, this is the sign I have, I got to put it out there. Click. All this information is available in a pocket guide. And that pocket guide's available from Cornell. You have the contact information from Cornell. You can ask them to send you a hard copy of the pocket guide. Something else you can get is our app. Okay, why do we need a temporary traffic control plan? Because it may give us a wake-up call. We think about what we're doing before we get out there. Click, click. Oh, we didn't. You should be hearing beeping, beeping, beeping. And I guess we left that slide. You didn't want to show that one,
I
Amanda?
didn't hit the button to share the sound.
Okay, well, just go back to it. Go ahead. Click.
Beep,
And what's
beep,
happening is
beep.
we hear beep, 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 beep. Oh, it was a backup alarm on a truck. Okay. He didn't realize what he had. Click. Let's take a look at a work zone.
Hey, Al, real quickly, there's a question in the Q&A. Do
Yeah.
you always recommend using an end work zone sign?
It's a good idea to put up. It's not, I wouldn't be very upset if it wasn't up there. Usually motorists can see just by the operation that that they're leaving the work zone.
I always tell people, Al, if you have that person drive through it and they aren't clear that they're at the end of the work zone, put it up.
There you go. That's great. Thanks, David.
And we got about 5 minutes.
Okay, let's take a quick look at this and then we'll go to the last slide, okay? So here we click through, we got traffic control, equipment, material handling. And typically when people are looking at work zones, they only think about what signs do I have to put up. When you're thinking about planning out your work zone, this is a good example to take us through why it's important to plan out what you're going to do. So let's click here. And what we have is there's a municipality and they're going to be paving that north-south road. And the way the paving is set up, they're going to start the paving on the north end of the road and work towards the south end of the road. That east-west road at the bottom of the screen, that's where they're staging their equipment. And they're putting up barricades along the south end of the paving road, the work road. So let's click here. This is the east-west road. We're looking westbound. We can see that this is a busy arterial. There's bus traffic there. And the 123 truck that's coming out of the road that they're paving on, the truck that's on the left that's waiting to back up and deliver asphalt to the paving machine. There's stores on the left. Click. Here we're looking eastbound. We can see this is a bus route. The two buses are passing each other. We can see personnel have to be out in the roadway to help guide traffic and get the materials into the work site. Click. This is our work site. The road is completely closed off. They paved one lane and they're paving the lane on the left. Click. And this is the north end of the road. It's been closed off. And we can see that the paving's progressed quite a bit down the roadway. Now let's click. So this was the original plan. You can see where the staging area is. The staging area is on a busy arterial with stores there. Click. Maybe we could have modified the plan. Might have been better to close off the work roadway at the south end and pave going northbound. And then we could have used that east-west road on the north side as the staging area. And one thing to note is that's just a quiet residential street that actually cul-de-saced. So very little traffic, very little interaction. We wouldn't have closed down the business area. We wouldn't have had our work people standing out on a busy highway. Click. Same paving project later in the day. Click. Oh, somebody else is back there. What are they doing? Click. It's a utility company. Click. And what happened was when the paving operation went through, even though they put in adjustment rings, they paved over the manholes. So this crew actually followed the paving crew around on every one of their jobs. And this is ridiculous. Why are these people working out there? Why didn't they just embed a person with the work crew to make sure that that they did a good job at cleaning off this utilities manholes? So if we would have planned this out better, we could have saved this crew from coming back, and we could have kept our crew safer. Click. And here's an example where a crew says there'll only be a minute. I'm only going to be a minute. This won't take a minute. Go ahead. Okay, what's happening here is this is a news report, and the crew pulled up a manhole cover to inspect the manhole, and they saw that they were going to have to do some operations to flush it out. And they walked about 10 or 20 feet away to their truck, but they left the manhole cover off. And this young girl, Alexandra, was walking along with a friend, but they were chatting and texting, and she stepped into the manhole and fell about 5 feet into the manhole. And of course, there's now a liability. And unfortunately, what they did is we're only going to be a couple of minutes, and they didn't put the manhole cover back or cone it off. So think about what you're doing out there. Slide. What do we want to do? Slide. Have a traffic control plan, follow the manual, minimize traffic control devices, remove our devices, and train all our people. So hopefully you picked up one thing today. And as you go back out into the work site and you're working out in that busy traffic, one thing, maybe you just pick up your head and you don't step out from between those cones, and you go home safe today. Click. We all want to get home safely. Okay, for those of you that are interested in PDHs, we have a quiz for you. Go ahead. And Amanda, are the answers coming in? I think some of you are just having fun with me. Okay. Okay, we want to fulfill a need. Okay, most of you got it right. And some of you are just having fun with me. Can we click? Okay, think about our mathematics. How do we handle this problem? We got to convert the 30 miles per hour to feet per second, and that's 250 feet. Click. Okay. What is it? 225, right? There it is. There's one of the bigger vehicles that goes through a work zone. What color is used for work zone signs? Okay, we got it. Ah, great. Okay. Overwhelming. We're still getting the sign colors. Okay. Okay, there's a common mistake there. Okay, it's manual on uniform traffic control devices. There you go. We got it. Okay, manual on uniform traffic control devices. MUTCD, M-U-T-C-D. Okay, next slide, please. And technical assistance, the Cornell Local Roads will be putting on some more programs. If you look at the packet that they sent you, there's more webinars coming your way. There's a lot of resources, booklets and training material, and the packet they sent you gives you information on how to download a digital copy of the MUTCD, the New York State Supplement, and the sign handbook. And David, I'll turn it over to you. Thank you.
I
Next
was
slide.
gonna say thank you, Al.
Click.
And you guys can all go on our website, get information. If you haven't opened up the chat pod, that information is available. The handout that Al mentioned. These will also be posted along with the recording of this webinar on our website, which is listed right there. You can also just search for us. And then finally, we'll get your certificates of attendance here pretty quick. And then for PDHs, we'll be following up with that if you were here for most of the time, 90%. With that, Al,
David,
thank you very much. Yes,
did-
Al.
The people who want PDHs, do they have to do anything?
No. Well, they need to let us know they want one. If they,
Okay.
they should let us know. It's easier that way. Just let us know.
And who should they email?
They can just email our general email down there, the CLRP@cornell.edu.
Very
All
good.
the instructions are in the are in the email I'll send later today.
Thank you.
Yeah, Amanda and Adam take care of all the hard stuff. I just sit here with a background of snow. And
Amanda, thanks for bailing me out.
Not a problem, Al.
You did a great job. Thank you.
thanks, Amanda. Thanks in the background, Adam. Take care, everybody. Have a good day.